Hello everybody, this is the second video about assembling this skid steer loader. In this video I will show you the process of assembling the body and lifting arm, and also the process of laying cables and connecting all electronic elements. I think this video will be useful to you because in the past a lot of people have asked me about recommendation for connecting all electronic elements. So let's get started. I start assembling the body by preparing the parts. First I insert them 3 nuts into the front body piece. Then I added the round head screws that will hold the cap in place in the future. After that I insert them 3 nuts into the rear body parts. To prevent the nuts from falling out, you can glue them or solder them using a soldering iron. Now I started assembling all the parts into one. If you have a printer with a large print area, then in the folder with alternative parts you can find front and rear body parts combined into one. The combined part will make your assembly process a little easier. At the end of the assembly you also need to add an M3 round head screws at the rear. In the future this screw will keep as the tailgate closed. After assembling the body parts, I recommend soldering them all together using a soldering iron. This will increase the overall strength of the structure. At this stage the body assembly is completed and I move on to assembling the lifting arm parts. First I connected the front and rear lift arm pieces and then added the rear frame. After that I decide to glue the parts of the lifting arm together. I unscrew the screw a little so that glue could penetrate between the parts, and then I tighten the screws again. Next I went back to the body and installed the rear corner pieces. After that I placed the body on the chassis. I think this will simplify the next process of assembling the model. And now is the time to install linear actuators. Now it's time to complete the assembly of the lifting arm and install it on the model. I check to see if the wires are long enough to fit into the cable duct inside the lifting arm. As you can see, the wires is quite long, but the connector will need to be cut because it will not fit inside the cable channel. I also use a different type of connectors in my model, so I had to cut the connector anyway. Before I push the cable through the cable duct, I trim them and prepare them for soldering. Doing this now is easier than after pushing it through the cable channel inside the lifting arm. I also use shrinking tubing. The cable looks better in it. You don't need to use head shrink tubing for the entire length of the cable. You only need to hide the visible part of the cable. This will also save space inside the cable channel. Note that I cut and soldered the wires with the offsets, so I don't need to isolate them individually. I just need to place them in a common head shrinking tube. Here is my plan. I want to use this piece of board for prototyping and make it into a hub for cables from linear actuators and other things. Before soldering, I coat all contacts with soldering acid. I don't know which ones I will use in the future, so I soldered all of them. Next I soldered the connectors for the wires from the linear actuators, which are located in the front of the lifting arm, and I use it to tilt the bucket. I plan to place these small speed controllers between the pulleys, so I measure out the required length of the wire and then solder the motor control wires to the hub board. The holes in the board are smaller than thickness of the wire, so I drilled them out using a 2mm drill. After that I connected the wires from the speed controller to the connectors located on the sides of the hub board. Now I am connecting the control equipment to the motor controller to check if everything works well. If you have the same problem as me, that linear actuators move in opposite directions, no problem, just change the position of the wires on one of the connectors. Behind the camera, in the same way, I soldered another speed controller and couple of connectors to control the arm lift actuators. I also soldered a third speed controller behind the camera to control additional equipment and 3-wire connector to connect a small servo which is needed to change tools. Here I soldered some plastic and drilled 1.5mm hole into it to install the hub board. Next I push a 2-core wire through the cable channel to control the motor of the additional equipment and a thin 3-core wire for a servo. And finally I screw the lifting arm to the body. And now it's time to assemble the tool holder plate. This is an improved version and it has tool changing mechanism, but you can also find a simplified version without this mechanism, but then you can use only one bucket, statically fix it to the holder plate. Before installing the servo arm, I connected the servo to the radio control hardware. This will rotate the servo shaft to the central position. Attention, don't forget to calibrate the end position of the mechanism, so as not to burn the servo. Now it's time to install the tool holder plate on the lifting arm. And the last step in assembling the lifting arm is attaching these black links. And now it's time to screw the body to the chassis. Small tests. As you can see, the lifting arm can already move up and down, and the tool holder plate can also tilt, but the servo and the additional channel are still not connected. And this is how I connected the servo. I hide the servo wire in the heat shrinking tube for a nice look, and I soldered a connector to the 3-wire core which is located in the lifting arm, and glued this connector to the lifting arm. It's not necessary to use connectors in this place, you can just solder the wires, but the connector gives me the opportunity to disconnect the servo at any time, for example if it breaks. On the back side I soldered a connector and attached it to the hub board. The servo installation is complete, and now I am doing my first practice in attaching the bucket. And last step is this wire for additional equipment. I wanna take this small part that must be glued here and cut these rounded pieces and insert pins from this XT60 connector. And later I will use second part of connectors I also removed pins from here and push them together. And now I need to clear space here for inner side of these connectors. I need to remove this screw, but before this I wanna melt everything here to improve and save strength of the parts. Okay, I'm weld parts together where it's possible, from bottom, from inner side, except exterior side to save nice look, and also I melt small hole from this to this wire channel, and now I push wire and I think it's fit well. Alright, and also I need to make small channel to connect top and bottom pins. And here is demo of working. I take these connectors from XT60 connector and here how it works. I used small speed controller and thin wires inside ARM, therefore this combination only can be used with small electric motors like inside this linear actuator. You can use it inside 4-in-1 bucket that I already designed, and perhaps I make later something like this or this. And you can make something more powerful with more powerful speed controller, thicker wires, for using, for example, with snow blower that I already designated. And that's all for this video. In the next part I will show you the process of assembling the cabin and also try to make a light control module. Subscribe to the channel so as not to miss a new video, and see you soon.